going to discuss about the MCQs related to chemical energy. So what is meant by thermal equilibrium? So thermal equilibrium is the place when you can say two bodies which are in contact, which are in contact, they are not exchanging heat. They are not exchanging heat. Why they are not exchanging heat? The reason is that because both bodies are at same temperature. They are at same temperature. And what is happening because of it? When they are at same temperature, that means they are going to have same kinetic energy. Why they are going to have same kinetic energy? Because we know temperature is directly proportional to kinetic energy. So if we see option C, they are saying two bodies have same kinetic energy, so their temperature is same. So right answer is going to be C. So in the next question, first of all, we have to see a basic principle, like for example, exothermic reaction. What happened? We know enthalpy change is negative. Okay. And in these reaction, what happens during bond formation? During bond formation, more heat is released during bond formation as compared to energy absorbed during bond breaking. So you are going to see one thing, that the both reaction are exothermic, enthalpy change is negative. So if we see option B, you are going to see that energy released in forming the bonds in the product, because bonds are formed in the product, is more than the energy required to break the bonds. So the answer is going to be B. Remember, for endothermic, what happens? Delta H is positive, and here energy absorbed during bond breaking, that would be more as compared to energy release during bond formation. So in this question, they are saying which statement about energy diagram is correct. So if you are going to see, I have drawn the energy diagram for exothermic reaction and for endothermic reaction. So like we can see, if we see option A, the energy diagram for exothermic reaction has reactants at higher energy than product with the positive enthalpy value. No, it is going to be the negative enthalpy values, because you can see here. Then energy diagram for endothermic reaction has the reactant at low energy, absolutely right, then the product with the positive enthalpy change. This option is absolutely correct, because reactants are at low energy, products are at high energy, and enthalpy change is also positive. So this option is right. So in this question is about thermal equilibrium. Okay, so now what happens? A metal spoon is placed in a cup of hot coffee. Which statement best describes the heat transfer process? So as coffee is hot, so this is metal spoon. So heat always transfer from hot object to cold object until the temperature of both objects becomes the same. So if you see option B, heat flows from the coffee to the spoon until both of the temperature becomes the same, and when they become same they are at thermal equilibrium. So in this question they are saying which statement about dissolution of ionic compound is right. First of all, enthalpy of hydration is always an exothermic process. Absolutely correct. Why? Because enthalpy of hydration is when Na positive is like developing a force of attraction with water molecules, like oxygen is having partial negative charge, so they are developing ion dipole force. Dipole is in on oxygen, so they are developing ion dipole force of attraction. Like chloride ion, they are developing the force of attraction with hydrogen. Okay, so that is also ion dipole force because it is having partial positive charge. So as the force of attraction develops, so this is going to be the exothermic process. Remember, when force has been developed, when force of attraction has been developed, that is an exothermic process. Now, if they are saying if lattice energy is greater than hydration energy, the dissolution process is endothermic. Lattice energy is always endothermic, and enthalpy of solution here is equal to lattice enthalpy plus enthalpy of hydration. So if this value, as this is positive, if it is greater as compared to this value, because it is exothermic, it is going to be negative. If this value is greater than this value, then what happens? Definitely enthalpy of solution would become positive, and if enthalpy of solution becomes positive, then we can say it is endothermic. So this option is also right, this is also right. But if we are seeing this one, this is wrong. Why? Because enthalpy of solution is equal to lattice enthalpy plus enthalpy of hydration. So that is what this one is wrong. So B option is right, which is saying 1 and 2 are right. So in this question they are saying ammonium chloride dissolve endothermically. When ammonium chloride dissolves, then they are going to form ammonium ion and chloride ion. So this is endothermic process. Why? Because bond have been broken. So what happens, like you can see heat energy is absorbed in it, and it is basically converting into chemical energy. So it is converted into chemical energy after absorbing heat. So what is heat? Heat is basically is the sum of kinetic energy in a sample. It is the sum of kinetic energy in a sample. So what happens when you are absorbing heat, okay, which is the kinetic energy actually. So that kinetic energy after absorbing is going to be converted into chemical energy. So kinetic energy is converted into chemical energy. So option B is going to be correct. In this question, we can see one thing. These are reactant and the product is this one. Now what happens? First of all, we can see one thing, that enthalpy of product, okay, you can say the energy of product is greater than energy of reactant. First of all, this is going to be the thing. Then we can see that if we are seeing the Forward activation energy. So forward activation energy is this much. This is the forward activation energy of the reaction. And if we are seeing the backward activation energy, that is for forward. First of all, this is for forward. And if we are seeing the backward activation energy, then it is going to be, let's draw it with the purple color, that is going to be this much. So you can see that forward activation energy EA for forward, that is greater than EA for backward. So let's see which option is explaining us the right thing. That if we see option D, they are what they are saying. First of all, the reaction is endothermic. Why? Because products have more energy than reactants. So this is right. And the forward activation energy is greater than the reverse activation energy. That is also correct. So option D is going to be the right one. So if we are seeing this question, if you see this place, what is happening at this place? That is melting. And for melting, we also call it as fusion. And the length of this place, this place length, what it is representing to us, it is representing the enthalpy of fusion. And if we see this place is representing the enthalpy of you can say vaporization. Okay, because what is happening at this point? Boiling is happening at this point. So guys, if you see this place, don't you think so this line D has greater length, than line B. So you are going to analyze one thing here, that it shows enthalpy of vaporization is greater than enthalpy of fusion. So the answer is this one, B, which you can see enthalpy of fusion is less than the enthalpy of vaporization.